Concrete is ubiquitous in the world. It is the material being used to build our cities and roads and our future. After water, it is the material that is used most by humans on our Earth. The energy demand and carbon emissions linked to the production process are significantly lower than for other mass materials. Concrete is produced from the most abundant elements of the outer Earth's crust. Hence, there is no viable alternative for concrete regarding sustainable and future-oriented construction. However, there are many challenges. Typically, concrete requires Portland cement as binder, the production of which is responsible for up to 10% of the global carbon emissions already today. And due to the rapidly increasing global demand, the emissions can be as high as 30% in 2050. Therefore, rethinking is overdue, and more environmentally friendly alternatives need to be found urgently. Avoiding concrete would not make anything better. But we can use better concrete and use cement in concrete more efficiently. But how can we make better concrete? There are various ways to master the challenge. Classical Portland cement can be partly replaced by more sustainable cementitious materials with a better carbon footprint. Chemical admixtures that modify the rheology help to minimize water consumption, which causes higher strength and higher durability. Ideally, both approaches are combined, which allows us to build higher and wider and to save material. In the industry nations, byproducts such as fly ash and blast furnace slag have been established for long. But on a global scale, their supply is limited and the resources are not equally distributed. Today's performance-enhancing chemical admixtures are typically based on crude oil and thus are not renewable. They are scarce and mostly prohibitive in many regions of the Southern Hemisphere, for example in most countries of Africa. Therefore, it is time to reconsider that Mother Nature already provides an overabundance of alternatives. Hence, the solution for more sustainable construction has always existed. Many ashes from agricultural waste products, such as rice husks or cassava peels, are reactive and can replace cement partly. Chemical admixtures can often simply be picked from nature, for example starch, cellulose or gum. The usage of agricultural byproducts also helps to avoid unnecessary waste and disposal sites, and in addition, the costs for building with concrete can be reduced. Furthermore, carbon emissions can be reduced by the use of plant-based byproducts. And new value chains can be created for local and international market players. Cassava, which is also known as manioc or mandioca, gives an excellent example for how new regional markets and sustainable concrete can become reality simultaneously, based on yet unused wastes. Cassava is a tropical and subtropical plant that grows on marginal soil and does not require much water. Its tubers are rich in starch. Following rice and maize, cassava is the third most important starch source in the world. It feeds more than 500 million people of the southern developing and emerging countries. Of all countries in the world, Nigeria produces by far the highest amount of cassava. Today, this is about 20% of the global and 35% of the African production. In Nigeria, the cassava production correlates with the population growth. The relevance of this resource thus grows day by day. For the food processing, the tubers first have to be peeled. Since the peels are indigestive for most animals, they do not qualify well for livestock feeding. Typically, they are simply dumped with all the residual starchy attachments and left to rot. The results are pollution and malodor. Instead of that, the wastes could be entirely exploited. Firstly, the attached starch can be obtained in a simple process. The obtained admixture contributes to higher strength and durability of concrete. The residual peels can now become a fuel, for example for brick production. The resulting ashes are suitable cement replacement materials. Hence, all byproducts from cassava processing can be utilized entirely for better concrete with less Portland cement. The outcomes are lower carbon emissions, cheaper yet better construction materials, short supply chains. The results are striking, and furthermore, there is no competition with food production since solely waste materials are used. The process is based on renewable resources. It can be repeated year by year. In addition, existing value chains can be amended by formerly not existing market potentials in the areas of construction chemicals and mineral binders. From alternative organic raw materials, new chemical admixtures can be developed in order to enhance the performance of concrete. The residual peels are an excellent fuel, and the resulting ashes can be converted into mineral binders, which supplement the retail market for more sustainable materials for construction projects. The reduced carbon emissions contribute to a better global climate, and cities and roads can be built at lower cost, better and more sustainably.